All right, let me shorten up my window here. Which one do you want to look at first? This one?
Well, it's all the same sheet, so it doesn't really matter, but yeah, why not?
Yeah, look, we might as well start at 1. All right. Instead of drawing the figures, I want you to take one point and tell me what happens to it. In other words,
All right.
let's take that vertex right there, which is at 2, 2. Where does it go to?
-2. 0, -2.
In other words, I'm going to take that point, move it 2 to the left, and down 4, which puts it at 0, -2. Correct. And you basically do that with all 3 points.
Okay.
Okay? About B. And again, we might take 2 points this time, but let's see what happens to this point. We'll call that point A.
Okay.
Yeah.
Well, it just goes.
So what's the coordinates of A prime?
2, 2 again.
2, 2. That'd be
after that point.
That'd be where it's at right now. It's currently at 2, 2.
Yeah.
So reflect it over the x-axis, and where does it end up?
-2, 2. 2, -2.
2, -2. In other words, whenever you reflect over the x-axis, you're just going to change the sign on the y-coordinate. That's it. If we look at this coordinate here, that's 5, 3. Reflect that point over the x-axis, and you get 5, -3.
All right.
So it's really straightforward. Now, rotating something. Let me do some drawing to explain this. This is the hardest one to handle, is rotations, at least for me. Different people handle these kind of problems differently. I have some students that are really good at doing this. Myself, not so good. This is kind of more on the order of 3-dimensional geometry for me. But when I rotate it counterclockwise, here's what I'm going to do. I'm going to attach every point to the origin.
Okay.
Then I'm going to rotate that line that I just drew 90 degrees counterclockwise. Well, 90 degrees means it goes to there. Counterclockwise means it moves in that direction. What is the coordinate of that A prime? In other words, if the coordinate of that is 2, 2, what is it once I rotate it 90 degrees?
How would I be able to tell?
Well,
what it is?
Usually with all of these things, whether you're rotating a point or a polygon or whatever, with rotations and reflections, the numbers don't generally change. What generally changes is the order of them or the sign on them.
Okay.
Okay, well, clearly, if I take that 45-degree line and rotate it, it becomes a 45-degree line, a -1 rather than a +1 slope. Well, then this point has to be -2, 2, right?
Okay. Yeah.
In other words, if this one is 2, 2, In other words, we don't generally come up with different numbers unless we're doing one of these. If we're doing a slide or a glide, then the numbers change. But if we're doing a reflection or a rotation, the numbers generally don't change. They may reverse their order or reverse their sign, but they're not going to change. And that's all you really have to remember, I think. Well, hold on a second. Let's see. So let's do one more point just to check. Let's see. That point would be 3, 7. Okay. And if I do the same thing, in other words, if I attach that to the origin, and then I rotate it 90 degrees, it's going to end up about there. And I know, let's be a little more specific on our 3, 7 rotates really more. Let me erase that one just to get rid of it from the drawing. We're going to rotate that line. So there's the right angle. There's the 90-degree rotation. What do you suppose the coordinates on that are?
-7, 3.
Yeah. And this kind of illustrates a key principle about rotation. And let me see if I can describe it to you. If I said, rotate the point 3, 4, 90 degrees to the left, those two numbers are so close together, 3 and 4, that if I visually do it, I can't actually figure out what the answer is. In other words, is this answer, even if I know the numbers aren't going to change, is that answer -3, 4, or is it possibly -4, 3? We can't really tell by visually looking at it. You with me?
Okay.
However, if I really want to know what you do, let's come up with a point like 5, 1. And let's rotate that 90 degrees. In other words, if you forget the rule as to what to do with the x and y coordinates, you can always figure it out by using two numbers that are a little further apart. In other words, if I make my 90-degree angle now, clearly, what must the coordinates be?
-1, 5.
Look at, there you go. -1, 5. In other words, if we know the number sizes aren't going to change, but it's just a question of whether we have to switch them and put a negative sign on it, clearly this is -1, 5. It's not -5, 1. Okay? So my point is that you can always figure out the rule by plotting a point where the numbers are a little further apart. So the rule when you do a 90-degree counterclockwise rotation is to switch the numbers and change the sign on the x coordinate.
Okay.
That's what we did here. We just switched 5, 1 to 1, 5, and we changed the sign on the x coordinate. Now, that rule might not always work. It depends on where the original point is. In other words, let's take this point here and rotate it 90 degrees more counterclockwise. What's the coordinates on this point?
-1, -5.
Look at the picture.
Oh, -5, -1.
That's why, see, you can see it whenever you're looking at the picture, right? There's no problem, as long as the numbers are far apart. If my numbers are 4 and 3, it's going to be much harder to tell. So what happened when we did this 90-degree rotation? Well, we switched the numbers, that's part of our rule, and we changed the sign on the x-coordinate. That's all we did. So whenever you do a 90-degree counterclockwise rotation, you switch the numbers and you change the sign on the x-coordinate. Now, you can either memorize all those rules, and a 180-degree rotation is going to be different. A 90-degree clockwise rotation is going to be different. So you can just memorize all of it. And to be honest with you, I have not done that. I always figure it out every time I encounter these. And the way I figure it out is to use two numbers that are relatively far apart, like 1 and 5. Then it's always crystal clear as to what you need to do. This problem here is a little tough because one of the numbers is 2, 2. Well, let's take that number, 2, 2, switch the numbers and change the sign. That becomes -2, 2. Which is exactly where we had, -2, 2. Okay, so let's test how well you have picked this up. What is going to be the coordinates of this point right here, 5, 3? That third one that we haven't looked at yet, after I do a 90-degree rotation.
-3, 5.
Okay, cool. You got it. Once again, on 2A, every point's going to do the same thing. This point right here is -5, -3. What's the new point going to be?
For which point?
This top point where my hand is here, the top vertice of that kite.
Okay.
Which is -5, -3.
All right.
And I'm moving it right 3 units and up 5 units.
Should it be -2, 2?
Yeah, let's see. What was the original? -5, -3. I'm going to add 3 units to the x-coordinate. I'm going to add 5 units to the y-coordinate. -2, 2. Okay, cool. And you would do that with all 4 of these vertices.
Yeah.
Okay, so in other words, when you do a slide, which is what this is, a slide or a glide, whatever you want to call it, if you can do a point, you can do a polygon. In other words, whatever you do with one vertex, you do with all 4 of them. And in fact, most of these are going to be like that. That's the same with what we did over here with 90 degrees counterclockwise. Whatever we did with that point, we were going to do with all of them. And what we did was switch the numbers and change the sign on the x-coordinate. Okay, how about number 2b? Let's take that same point, -5, -3, reflected over the y-axis.
That's just -5, -3, was it, the point?
Uh-huh.
So it'd be -5, 3.
reflected over the y-axis, it's going to end up over here.
Oh, okay.
Always make sure that your numbers make sense. In other words, one of the good reasons to draw a picture is that you can tell whether your answer makes sense or not. Your first answer didn't make sense because the x-coordinate was still to the left of the y-axis. We need the x-coordinate to end up right, or we need that point to be right there. What are the coordinates on that point?
5, -3.
Which means the only thing we did was change the sign on the x-coordinate. So a reflection over the y-axis, you change the sign on the x-coordinate. This problem up here, a reflection over the x-axis, we change the sign on the y-coordinate. You always change the sign on the other variable that you're reflecting about.
Okay.
And finally, let's do a 180-degree rotation. And even though they say clockwise, doesn't matter, right? In other words, whether it's clockwise or counterclockwise, it's going to be the same thing. Well, let's figure out the rule. In this problem here, I did a 180-degree rotation. I did it as a 90-degree and then another 90-degree. But what did I end up with? So what's the rule? What did I do to get from 5, 1 to -5, -1?
You just change the sign.
That's the rule. When you're doing a 180-degree rotation, whether it's clockwise or counterclockwise, you just change the signs. In other words, you don't switch the numbers. You just change their signs. So this point is going to go to what? Instead of -5, -3,
it's going to go to 5, 3.
how about this point down here, which is -5, -8?
It just goes to 5, 8.
All right, you got that rule down. Are you seeing what I'm talking about in the sense that you don't necessarily have to memorize the rule? You can always work it out by, as long as you use two coordinates that are relatively far apart. In other words, that have some small slope to them.
All right.
Because I can tell that when I take this point 5, 1 and I rotate it 90 degrees, I can approximate what that point must be. And as long as I know the numbers don't change, well, the only thing it could be is -1, 5, right?
Yeah.
Same thing when I rotate it another 90 degrees. It ends up here. In other words, it doesn't end up down here. It ends up there. That can only be -5, -1, assuming the numbers don't change. So that's the most important rule to remember, is the numbers don't change. They may switch places and they may switch signs, but they don't change. Not unless you are doing a glide transformation. Then they do. But those are easy. In other words, these problems A here, wouldn't you agree that those are a piece of cake?
Yeah.
All right. So let's forget 3A. 3B, you've shown me, you know how to do that.
Could we try 4A?
Well, yeah. Before we get to 4A, let's do 3C, because we haven't done 3C yet either.
Okay.
A dilation. Now, basically, what a dilation with a scale factor of 1/2 is going to do is it's going to shrink this thing by 1/2. And what you can do here is draw a line from the origin to each vertex and then cut it in half. Okay.
Uh-huh.
Let me see if I can approximate that drawing. To dilate this, start from there. Hope I'm telling you this right. I maybe should do my dilation. You don't do dilations very often, but I think this is the way to do it. If I'm mistaken, I'll correct myself later. You take that distance and you cut it in half, and that's the new. In other words, if this is A, B, C, D, then the new B is that point right there, B prime. The new A is halfway, that point A prime. The new D is right there, D prime. And the new C is right there, halfway, C prime. Connect the dots, and you end up with something that looks, and in fact is, similar to your original quadrilateral.
Okay.
Just half as big. All right, let's look at 4a, reflecting about y equal x. Now, this is actually a very interesting reflection because y equal x, anytime you reflect over that, you're talking about the inverse function. And this isn't something that's widely known, but there's the line y equal x.
Okay.
And it doesn't matter what kind of function I have. I could have a parabola, which is y equal x squared, and if I reflect it over that line, it ends up looking like this. But the one thing I remember about inverses is you just switch the coordinates. Whatever is the x coordinate becomes the y coordinate. Whatever is the y coordinate becomes the x coordinate.
Okay.
That's all you have to remember. So this point right here, let me see if I can reflect this thing. Let's see, that's one point, and there's the second point, there's the third point. There's two ways you can try to do this, and that's one, you can try to reflect the entire triangle over the line, or you can do it point by point. Each way is to do it point by point. What's the coordinate of that point right there?
-2, 2.
After I reflect it, it ends up down here. You see why?
Yeah.
In other words, let me label these because they've drawn this triangle in such a way that it's going to be quite confusing. So I'm going to label them A, B, C. B is 2, 2, and C is 2, -2. Okay? So the rule is you just switch the coordinates. So where is A prime?
Isn't it where C is?
Yes. In other words, when you switch the coordinates, you get 2, -2. So that is also A prime. It's a bad example for them to use.
Yeah.
Where is B prime?
Does it just stay the same?
Huh? That's why I said it's a bad example. And where is C prime?
Where A used to be.
Right. And so that's your line reflected over y equal x. Just switch the variables. When you reflect over the line y equal minus x, you switch the variables and change the sign.
Okay.
And let me show you at least one example of that. In other words, these are the standards that you have to reflect over: the x-axis, the y-axis, y equal x, and y equal negative x. Well, this is y equal negative x.
Okay.
And let's assume that I had that point -5, 1. Well, I can tell where it's supposed to go, right? Up here.
Yeah.
In other words, the way you reflect them is you draw perpendicular to that line, and whatever that distance is, you go the same distance perpendicularly on the other side. Well, if I know the numbers don't change, what does that have to be?
-1, 5.
So that tells us the rule. What's the rule?
You switch your x's and y's and change the sign.
Exactly. In other words, when I'm reflecting over y equal x, all I do is switch my x's and y's. But when I reflect over y equal negative x, it's pretty easy to remember that not only do I switch my x's and y's, but I switch their signs also.
Okay.
And I suspect that that's one of the next problems. Yeah, reflect through the line y equal negative x, and again they use the worst triangle they could possibly have chosen because it doesn't change. Although this one might. Well, I doubt it. Let's see, that we switch the numbers. They're all 2, 2. So if we
I think B prime switches, but
yeah, you might.
Other than
Yeah,
that.
you're right. It's going to switch to down here. In other words, it's going to become -2, -2. Yeah. Okay. And a dilation factor of 2. You do the same thing, only instead of cutting the distance in half, you double it. So this point goes out to here. This point goes up to there. And this point goes to 4, -4.
All right.
All right. Good place to stop. Let's see. Thursday at 4. Is that right?
Yeah. That's our next time.
Okay. So we're going to do Tuesdays at 4:30 and Thursdays at 4, unless I hear different from you.
Yep.
Sounds good. Mark, have a good one. I'll talk to you Thursday.
You too. Thank you, David.